This is the screencast for section 2.8, example 9. We're going to design a box again. The Dixie Packaging Company is making lots of boxes apparently, has contracted with another firm to design boxes with a volume of at least 600 inches cubed. So that's what's different in this problem. If you want to go back and look at how I set up the volume for this box, please go back to example 9 of section 2.3. But for right now, the volume of this box is 20 minus 2x times 25 minus 2x times x. Now that needs to be at least 600 inches cubed. At least. At the least. So it can be more. It can't be less. So I'm going to put that our volume has to be greater than or equal to, because it can be at the least 600. Now I'm going to use my calculator to help me do the rest. I graph the graph the function. I put in y1, 600. In y2, the volume. I found a great window. Yes, that's right, a great window. And now I can find the intersection points to determine where this function will be greater than or equal to 600, which will be between these 2 points of intersection, but also after this one, but I'm going to guess we won't be able to do that. So I'm going to find the intersection points. So after finding my points of intersection, I can definitely see that this guy is out. I cannot subtract 14.68 inches from each side of a 20-inch strip of cardboard, because I'd be taking out 28 inches from, over 28 inches, from a 20-inch piece of cardboard. So this section that's above the line y equals 600 is out. But any of these values, these x values, so from 1.66 all the way up to 6.16, those x values, if I cut a square corner out of this piece of cardboard that is any one of those x values wide, I will be able to create a box that's volume is at least 600 or greater. Here they will be exactly 600, but anywhere in between greater than 600. The now try problem for example 9 is number 59. So again, I've got an expression that represents the volume of this box after I cut an x by x size square out of each corner. The problem says that the Picaro's packaging plant wishes to design the box with the volume no more than, so it can be, but no more than 100 inches cubed. So 100 is our biggest. So this volume has to be smaller than or equal to, less than or equal to 100. 100 is our biggest volume it could possibly be. So again, I'm going to graph 100 in y1 and then the expression for the volume in y2. Find an excellent window. And then on my graph, I can find those points of intersection to see which x values, so which dimensions of the squares, will produce a volume of box less than 100. So that's going to be between 0 and whatever that intersection point is. And then from that intersection point to here, I don't want a negative volume. I do not want to create a black hole. Poor person I give this gift to, I guess. And then that's going to be questionable out there. Well, anyway, I'm going to find these intersections. So now that I found the intersection points as well as the zeros, so where the y values are significantly changing from either positive to negative or from below the 600 line to above the 600 line, I can start to look at what would be reasonable to cut out of this cardboard box. I can cut out 0.69, is this inches? Yeah, inches, all the way up, from 0, because this is 0, 0. From 0 all the way to pick 0.69 inches. And I can include those because, well, I guess I wouldn't want a box with 0 inches, so I'm not going to include 0. But 0.69 inches would make the volume of this box exactly 100 cubic inches, so that would be okay. The values between 0.69 and 4.2 inches for the x would be a volume too big. So how about then from 4.2, and we can include that, 4.20, which makes the volume exactly 100, all the way down to 6. Now I want to make a box, so I can't include 6 because 6 would make the flat box, which isn't a box. Then so then here's where I come into the problem. I can't cut out 6 inches from each side of a 12-inch piece of cardboard. Like I said, it would be a flat box. It would just totally fold in half. But anything bigger than that, I wouldn't be able to cut out at all because I can't cut out like a, let's see, 7.5-inch length from both sides of a 12-inch side of cardboard, because I'd be cutting 15 inches out of 12 inches. You just can't do it. So these are my values of x that would create a volume of less than or equal to 100 for this cardboard box.